So these are the stop words that will be skipped. The next one, we are going to see about exclude content in the search text. That's very easy. Similar to Google search, you just need to put a negation mark. So in the above search, if I'm going to mention that I don't want cream in the result, it will list only 2. So that's negation. It's similar to Google search. So this is for negation. Now for multiple search, that's very easy. I wish to have these 3 words to be listed in the search result. On firing this query, we must see the search result has the new words also included, importance and query. So this is how multiple search works. The next important thing is case sensitive search. That's very easy. As you can see in the syntax, case sensitive search, we just need to specify Boolean value. So we are going to use the same one, but this time this will have a different result, because as you can see here, one of the result is having a capital letter word in the beginning. That's coffee shopping is having a capital letter C in the beginning. So this will get filtered out from the search result if you are going to make a case sensitive search. Let's see that. That's very easy. Case sensitive is true. So the results will be 4 now. As we expected, the result is 4. That's how case sensitive works. Now let us search the exact phrase. Again, this is also very easy. I'm going to take this one. I'm going to paste this one here. Coffee and cream. But this is not an exact phrase. This will list all the ones with coffee and cream. So to make an exact phrase search, you just need to add this one here as well as at the end. So this will get you the exact phrase like this. So this is how the phrase searching works. The next interesting thing is the diacritic search. If you see the syntax here, there is an option for diacritic sensitive search. So you just need to specify a Boolean value for this. So in our collection data, if you can see here in this field subject, there are 2 values, cafe con leche. I think this is in Spanish. Similarly, there is the same text is repeated here, but in this one you can see a diacritic mark over here. That's the apostrophe. So if you make this one diacritic sensitive, it must only fetch exactly the same text if you are going to specify this in the search text. Let us see how this is going to work. Instead of case sensitive, we are going to give diacritic sensitive as true, and here this is going to be this search text. View document. Let me copy this one. paste it here. So we have the apostrophe mock here. On execution, you must see only the exact text searched here. That is because we have specified this as diacritic sensitive. In the previous versions of MongoDB, diacritic sensitive was by default true, but in the later editions they have made this as false. So if you're going to make this one as false, you must see two rows here, two documents selected, because diacritic sensitive is false. So the one without apostrophe mock is also got selected. But when we make this one as true, we must see exactly one document which has a matching apostrophe mock as specified in the search query. The next key thing we'll be learning is about the text score. The text operator automatically assigns scores to each document in the search results based on its relevance. So we're going to display it. For that, we'll be using the meta projection operator. So it's a projection operator, so it comes in the second part of the find query. The syntax is very simple, as you can see here. So let me copy this. This must display the scores associated with the search results. I'm just going to replace this query with a text operator. So this is the one, and the collection name is going to be articles. On execution, we must see the documents listed along with their meta score, the text score. So this is the score for the documents. To sort the results, it's very easy. Just you need to specify the same inside the sort method. I think I made a mistake here. Braces was missing. Let me add that. So the documents got ordered by the score. That's what the sort method does. So with this, we are successfully finishing about full text search. Now let us move to the next chapter. JavaScript in MongoDB server. For sure, we all know that MongoDB is JavaScript capable. Though MongoDB has many commands and many inbuilt methods, without you able to create your own JavaScript code that will run on or run against MongoDB, it is like repairing without a toolbox. JavaScript powers anyone who wants to work efficiently with MongoDB. JavaScript's main application in MongoDB is in admin jobs. In addition to that, JavaScript plays a key role in data analysis and manipulation also, so that there is no need for you to pull the entire data to the server side to do analysis. You can directly embed a JavaScript code and run it on the server itself using eval with query. Previously, there was a method by name db.eval which has been deprecated from MongoDB version 3. It was very useful, so that you can write your own function within a eval method and execute it against the database. But unlikely this has been deprecated, I hope mainly due to the security reasons. The third feature of JavaScript is that the MongoDB shell is REPL capable, so you can just use like that, like any JavaScript parser. To understand and see how JavaScript is very useful in MongoDB, we'll be using these 6 simple demos. To start with, we'll be using JavaScript in the shell. Then we'll be comparing JavaScript methods with their command equivalents. After that, we'll be doing a simple demo on cursor. Then eval method. Eval is deprecated, but till now it is very useful. Then we have the interesting one, though it is not a recommended practice. We'll be saving the JavaScript itself on the server directly. using system.js. Then finally, we'll be seeing how to run an external JS file through the Mongo command line. So these are the 6 simple demos we are going to see now. Let's start with JavaScript in shell. I'll be using RoboMongo. To start with, I'll create a database. JSDemoDB. And in this, I'm going to create a collection. Collection.js. Let me open a shell for this one. We got a shell now. To start with, I'm going to insert some documents with random numbers in that. I can use the JavaScript loop here easily. The shell can be used just like a JavaScript REPL. I'm going to do an insert here, db.collection.js.insert. I'll be selecting a simple document. Let me name the field as a random number. And the value is going to be math.random. I'm going to insert random numbers between 1 to 100. You can easily access JavaScript native functions from here. So to insert, we'll be using *100 plus 1. This will create random numbers from 1 till 100. So you can see here I have used the JavaScript library. Let me execute this. Braces are closed. On execution, I must see records getting inserted. View the documents in table view. You can see random numbers being inserted in the document. So what we have seen is we have just used JavaScript functions to create this random number. Now let me show how to use a JavaScript variable to filter the same. Filter max equal to 50. I'm going to do a find query to filter all the values whichever is greater than 50. Find the field name is random number. Let me copy this one. Random number greater than 50. Let me cover this with braces. So braces are there everywhere. On execution, we must see only the random numbers with values greater than 50 got listed here. So instead of having this value, you can also use the variable here. That's very easy. The result will be the same. Okay, I haven't executed this one, so I need to execute this so the variable get initialized. Then I'm going to execute this. So we got the same result as that of the previous. You can use JavaScript variable inside your queries easily like this. And similarly, you can access JavaScript functions inside your queries like this. So this shows us how we can use MongoDB shell to use JavaScript. We have seen about JavaScript in shell. Next, we are going to learn about MongoDB JavaScript methods and command relation. For this, you need to visit to this link, that is write scripts for the Mongo shell. This is under the manual. In this page, there is a subtopic differences between interactive and scripted Mongo. Click on this. A table showing the shells with corresponding JavaScript equivalents are listed here. For example, you can use this command show databases in the shell to list all the databases available, or you can use the JavaScript equivalent like this, db.admin command list databases. This is also going to fetch the same results. Similarly, for collections, you can either use a shell one, that is show collections, or you can use the db.get collection names. This is in JavaScript. And finally, we have cursors. So cursors are generally used along with the find method, which is going to return a set of documents and then you can loop through it. So let us see that. Cursor is a handle or pointer to a set of documents which are returned by a query. For example, if you see the definition for the find method, it returns a cursor to the resultant. A cursor to the documents that match the query criteria. This is the return type of a find method. Using cursor is very easy. I'll be using this collection over here. If you view the documents in the collection, these are the documents in table view. It has a field by name random number which has numeric values. So the same using cursor works like this. The return type is a cursor. So the results are saved here. I mean the handle to the results are saved here. The next step is to loop through the cursor. So loop through the cursor, that's easy. We'll be using the while loop here. Cursor has next method. One more thing I have forgotten is, in the documentation you can check about the methods available in a cursor. Under reference, Mongo shell methods, cursor methods, you can see the methods available for a cursor. So here the definition for has next is given, returns true if the cursor has documents to be iterated. So that's what we are checking while cursor.hasNext. The next one is the next method, which returns the next document in the cursor. We'll be using both of these methods here. Print JSON cursor return dot next. On running this, we must see the documents in JSON format. We got the result in JSON format. If you want the field value of random number, you can easily do this. And then on executing, we will be seeing only the random number values here. One more thing is, I am going to insert the cursor values into a new collection, that is test collection copy. db dot collection days dot insert. Sorry, this is test collection JS. Copy dot insert these values dot next. So on running this, we must see this new collection populated with the same values of this collection. So prior to that, let me show the values in this collection. It's empty. After running this, let me check the collection again. The values got copied to this. Here we used cursors for this. So cursors completely give you control over the return result. You can play with that. Now let us move to the next topic, that is using eval. The next interesting and useful thing is the eval method. The command equivalent for the eval method is the eval command. As you can see here, this is available in the documentation page. It's under query write operation commands eval. Similarly, the JavaScript equivalent for eval is db.eval. The only sad thing about this is it is deprecated since version 3, but it's very useful, very handy. This is the syntax for that. Let us see an example of how to use that db.eval for JavaScript. Let me copy the syntax. So this is the syntax. Let me make a simple method first, add method. The add function, which will take two parameters, x comma y, and it is going to return x plus y. Now the next is the argument. So I have created the function here. The function is here. So the arguments I'm going to specify as 100, 200. Let me execute this. So you can see the warning here, db eval is deprecated, but the result also has appeared. It's 300. This is the syntax of db.eval. A function is taken as a first parameter and the method arguments for this. For a complex example, let me show the values in this document first. In tabular view, it has a random number field with numbers. We are going to use eval to find the sum of all the random numbers here. We'll be using cursor for this. The first step is to have a find one here for this. Let me copy this. The result is going to be saved in a cursor. The next step is to loop the cursor. Create one more variable here. Cursor.next. The column name is random number. I hope, let me cross check it again. Random number, or let me view it. The final step is to return this addition value. So we have a simple eval function, which is a sum which operates on cursor. It has to return the total sum of all the random numbers in the collection. So we got the result, that is 5135. That's the sum of all the random numbers in the collection. This is the use of eval method, but sadly it has been deprecated from version 3. Now let us move to the next topic, that is using system.js. This is also not a recommended practice, but to know that, it is good. Using system.js. So under documentation of MongoDB, if you can navigate to store a JavaScript function on the server, There is a note is given here clearly that do not store application logic in the database. This is mainly due to performance limitations. But in few conditions, we may need to save JavaScript function on the server side. So for this, there is a special collection by name system.js where you can use a save method to save a function like this, where id is the name of the function and value is the function content. Do remember in the previous section we have seen about db.eval, in which we have used a function sum to do a sum of all the random numbers here in this collection. I'm going to use the same, but there is a minor change that this will be saved in a different database. So you need to get the database reference here, db dot get siblings. So you can see the method here, db.get sibling db. This will get you the database. So in our case it is js demo db, js demo db. Let me copy this one. We got the database, and on this database we are getting a collection, and on the collection we are performing a find, and using cursor we are adding all the random values that is present in the collection. So it will take a sum of all these random values. I'm going to copy this to the db.system.save. db.system.js.save method is the one we are looking at. The first argument is going to be the id for this, and the second one is going to be the method. So for the id we'll be calling this as sum of random, and the value is going to be the function. We don't need any arguments here. We got id and the value. I just need to close this brace. Yes. So on executing this, expect token in line number 3. Yes, I missed a circular brace here as well as a circular brace here. So now this must work. So a new record has been created. We have a function by name sum of random. If you refer to the documentation, before executing the function, we just need to call the load server scripts. So let me call that one first. The next step is to call the sum of random. On calling this, we got the output. So this is how it works. Let me recollect what we have done now. We have created a function by name sum of random, and we have saved in the database using db.system.js.save. In the function, for the value part, we got the reference to the database, then we got the collection, then using cursor we are doing a sum of all the random numbers and returning it. Before calling the function, we have called load server scripts, and then we have executed the function which resulted in this output. This is how to save a server-side JavaScript function, which is similar to a stored procedure in the SQL world.
GridFS, this is one of the interesting and important feature of MongoDB. Using GridFS, you can save files of size more than 16 MB directly into Mongo database. GridFS is widely popular in saving audio, video file formats, PDF documents, scanned images, etc. Learning GridFS is very simple. You can learn it in less than 10 minutes of time. Companies like McAfee and Pearson are using GridFS in their live environment. For example, McAfee is using GridFS for pushing updates and Pearson is using for saving students' data. As I mentioned earlier, there is a 16 MB file limit for a BSON document, which can be easily overcome by using GridFS. GridFS is similar to blob, that is a binary large objects data type in our traditional database, but the architecture is completely different. GridFS supports partial retrieval as well as distributed storage. We'll be seeing how GridFS works using Mongo Booster software. This is very easy and you can learn it in minutes. GridFS is very useful while development and in testing applications. Let us see more details about GridFS. The first step in GridFS is to add a bucket. We'll be using Mongo files command for that. A bucket is nothing but a virtual namespace, which in turn has two collections. One is for saving the file chunks, the other one is for saving the file's metadata. So when a file is uploaded or added to a bucket, it will be splitted into file chunks. The file chunks will be of size 255 KB. The details about the file chunks will be kept under a different collection called FS files as metadata. We'll be seeing more details about GridFS in the MongoDB documentation page, and there is a very useful use case documentation is also given in the documentation page. We'll be seeing an overview of that also. This is the GridFS documentation page. The most important thing is when to use GridFS. There are three use cases given. GridFS itself acts like a file system. So when your operating system file system has a limit on the number of files listed in a directory, you can use GridFS. And similarly, the most important thing is GridFS supports partial retrieval. And finally, it mentions about the geographical distribution of the data. So these are the three main use cases for GridFS. Out of these three, these two are very useful. The next one is about using GridFS. As I mentioned earlier, we'll be using Mongo files command line. And about GridFS collections, we have two collections. One is for holding the file chunks and another one is for saving the metadata. Actually, the names might have been better. This one might have been made as meta rather than as files. In the additional resources section in the bottom of the GridFS documentation page, there are two links. These links provide a greater insight and very good use cases for using GridFS. For example, on clicking the first link, that is for building MongoDB applications with binary files using GridFS, part 1. There are three main portions of informations. The first one discusses about the basics of GridFS. Then a short brief about how GridFS is practically used in McAfee and in Pearson is given here in the second portion. The third section discusses about the advantages of using GridFS for a medical system or a healthcare system. In healthcare systems, the patient's records are saved in X-rays or in MRI images. An average healthcare system can have data around 50 to 100 terabytes. The advantages of using GridFS for healthcare system are listed here. The first advantage is about simplified, centralized, and unified interface. The second one discusses about retrieval of the chunks, the files using MongoDB query language. The third one points about high availability of replica sets. The fourth one is about security model, and the fifth one mentions about how to use GridFS system as a replacement for your file system. Because by using GridFS, you can easily overcome the limitations of file systems, such as how many documents can be there in a directory, as well as the strict file naming rules. The part 2 of the article provides us with two very useful informations. The top portion discusses about how GridFS works. This diagram can easily give you a good idea about GridFS. For example, this JPG file gets uploaded to the bucket system of MongoDB using a MongoDB driver, which in turn is saved into two collections, files and chunks. Files will have the metadata about the JPEG file which we have uploaded, and the real data is saved in the chunks. Following this, there is a very useful and practical example of how to save video files and images to a GridFS system. The author of this article has used Perl language for explaining this. Though it is in Perl, it is very easily understandable. This has quite a good information about GridFS. Please go through this as well as the top portion which explains how GridFS works. So totally there are 5 informations we can gather from the part 1 and part 2 of this article. Now we are going to see a simple demo using Mongo Booster, which will just take less than 5 minutes, and you can easily understand how GridFS works. We are in Mongo Booster now. I'm going to create a separate database for our GridFS demo. Note that in real life scenarios, there is no need of a separate database for GridFS. Create database. Let me name it as a db underscore gridfs underscore 1 underscore demo. So this is our database. It got created. The next step is to add a GridFS bucket. Note that we are not adding a collection. We are going to create a GridFS bucket. Once you click create GridFS bucket, it will be prompted for bucket name. The default name is FS, that you know. I'm going to give a different name here, that is personal videos. On clicking OK, you'll be seeing a personal videos bucket got created. Under that, you can watch there are 2 collections. One is a files collection and another one is a chunks collection. The files collection has metadata about this chunks collection. Under this chunks collections, the real data will be saved. That we have seen already. So let us see that practically. To start with, I'm going to view the documents under files collection. Right click here, view documents. Initially, it has to be empty. It is empty now, since it's a fresh bucket. The next step is to add files to the bucket. That's very easy. Click on this plus symbol here. One more thing, there are 2 options here. Either you can add a file or a folder. I'll be going with files now. I'm uploading a AVI file. Once you have selected the file, you'll be prompted with a confirmation prompt to add with full path or without path. Option without path. Upload started. File got uploaded successfully. The file size is around 24 MB, so it is greater than the 16 MB limit which is imposed by MongoDB. The interesting and the important thing to note here is the chunks. We know that it will be saved in chunks of size 255 KB. Click view documents. So these are the chunks. If you want to see in JSON view, it's running on my PC, so it's taking a long time. This is the JSON view. So binary data is like this, saved in 255 KB. You can also play from here by clicking view file. Since it's a AVI file, I'm saying you can easily play here. So the AVI file got open. This is from MongoDB, not from my local machine.
Hi.
And one more thing, let us view the details, that's a metadata, JSON view. Chunk size is given and the file size is given here. Content type. So this demos us how GridFS works. So this data is saved in chunks, whereas the files will have the metadata about that. We have used Mongo Booster's tool for this GridFS demo. I'll be showing the same through command line also. In our previous demo, we have seen how easy GridFS is while using Mongo Booster. It was just like attaching a file in your email. This section will be seeing about Mongo Files command, which is similar to the Mongo dump or the Mongo executable files present in the bin directory of your MongoDB installation. Mongo Files command is very simple. As you can see here, it just takes 3 parameters. The first one is options. Here we'll be specifying the database, collection, host, username, password. The second one is the commands. This is for the CRUD operation, that is list, put, get and delete will be coming under this command session. And the third one is the file which we are going to act on. So let us see a demo section using Mongo Files. I personally don't recommend using Mongo Files because it doesn't have the option of creating your own bucket. So by default, it will save in the default bucket name, that is FS. That is the restriction with Mongo Files command, which we don't have with the other clients like Mongo Booster or Mongo Chef. This is the bin directory of MongoDB. You can see Mongo Files under this. It's here. This is along with the MongoDB, Mongo executable files. We are going to use this one, Mongo Files, for our GridFS. This is the Mongo Files documentation page. The syntax of the command is given here, followed by the options. Various options are listed here. Then the commands. Examples are given. Now let us work with the Mongo Files command. Mongo Files is the application name. Let me type that here, Mongo Files. Then the option D stands for database. Our database name is db gridfs1 underscore demo. db gridfs underscore 1 underscore demo. The operation what we are going to do is put. So put is the command name and then the file name. The file name is Google Drive. So this is the file name. Yeah, that is because of the space here. Successfully added the file. The next step is to list the files present in the grid. So instead of put, we'll be using list command here. Perfectly listed. The issue with Mongo Files, as I have said earlier, is that it will be adding the files to the default bucket name, that is FS. Let us cross check the same here. As you can see here, Mongo Files command has created a default bucket name, that is FS. There is no option currently available with Mongo Files command to create your own bucket name. This shows us how Mongo Files command works. We have used the put for adding the file and we have used list for listing the files. There are other commands that you can try by yourself. Basically, this demo is to understand how Mongo Files works and what is the limitation of Mongo Files. As I mentioned earlier, Mongo Files don't have the option to create your own bucket name. For example, we have created the personal videos bucket name by using Mongo Booster, but in Mongo Files, we don't have that option.
We are in one of the important topic of MongoDB, that's aggregation. Next to queries like find, insert, update and delete, aggregation is the most frequently used feature of MongoDB. There are three types of aggregation. Aggregation pipeline, this is the most frequently used recommended way of doing aggregation. The second well-known way is called MapReduce. This is used in big data systems, as you know. The third one is single purpose operations, which has only three methods, that is count, distinct and group. My personal favorite was MapReduce, but recent days I started using aggregation pipeline because this one is very less error prone and faster when compared to MapReduce. But do remember that MapReduce gives you a complete freedom when compared to aggregation pipeline. Let us see the MongoDB documentation which explains about aggregation. Really, it is one of the very good place to learn about aggregation. They have given a good set of diagrams to explain how aggregation pipeline works, how MapReduce works. With the diagrams, you can easily understand about aggregation pipeline and MapReduce. This is the documentation page for aggregation. As you can see here, aggregation pipeline is listed, MapReduce is listed, single purpose aggregation operations are listed. To start with, let us start with the aggregation pipeline. From the name itself, you can infer that it will have multiple stages. So one of the well-known stages are match, project and group. This diagram can give you a good understanding about aggregation pipeline, how it works. 4 documents are given here, each have the same structure, customer ID, amount and status. In the first stage, they have used match to filter the documents with only status A. So out of 4, 3 documents have status A. So those have been filtered here using the match stage. The next stage is a group stage where the records are grouped based on their customer ID. For instance, in our case, we have 2 customer IDs matching A123, A123. So they are grouped into a single result and the total is calculated using their amount. In our case, it is 500 and 250. So it will be 750. And for the second record, it is a single record. So B212 is placed here with the total amount of 200. So this is the result of this aggregation operation. So from an input of 4 records, we got a result of 2 records or 2 documents. Like a match and group stage here, we have around 15 pipeline stages, but we'll be using only 6 of them frequently. We'll be detailing about this 6 and we'll be seeing with examples in the upcoming sessions. Now we have seen about aggregation pipeline. The next one is about MapReduce. In the same page, MapReduce is listed. On clicking this, a diagram explaining MapReduce can be found. MapReduce is very simple. You may need to write your own JavaScript functions for map and reduce operations. The same data which we have used for the aggregate pipeline is used here and the steps are explained using MapReduce. So the first step to filter out the records is called query. The same one what we have used for aggregation pipeline, it's called match, where we have matched the records or the documents with status A. So in this case, this one is done by the query. The query filters the records first. So that's done. The next step is to map using the customer ID. So for that, you have to write your own JavaScript function. So the columns are selected here in map, and in reduce will be summing the amount. The same way we did in the group stage. Group sum we did the same way it has been done. I'll be explaining about this clearly in the upcoming videos, so you can easily master the things. It's very simple. So let me recollect what we have seen. In aggregate, we have many stages, around 15 stages, out of which 6 will be using quite frequently. In the example given here, the match and group stages are used. And in case of map reduce, map and reduce are used. In this case, you have to write your own JavaScript function. It's very easy. The result is going to be the same. The final one is a single purpose aggregation operation. It's very simple. It has very limited functionality. As you can see, we have only 3 functions mentioned under this. I mean 3 methods. The first one is count, the second one is group, and the third one is distinct. You can easily understand their meaning from the name itself. Count is for counting the records. Group is for grouping the records. Distinct is to find the unique values. It is suggested not to use a group, which is under single purpose aggregation operation. So if we click on this group method, in the documentation, it is highlighted that the group uses JavaScript. It is subject to number of performance limitations. So they have suggested to use a group operator in the aggregation pipeline. So let us start with the single purpose aggregation operations. We won't be covering group initially, we'll cover it later. Initially, we'll be seeing about the count method and the distinct method. Then we'll be starting with the pipeline operators. I mean the aggregation pipeline operators. It's very easy and interesting and one of the most essential feature of MongoDB. For the aggregation demo, I'll be creating a separate database. That is db_aggregation demo1. Database is created. The next step is to create collection. The collection name is WebRank. It will have the list of websites and their total visits. The document structure is very simple. As you can see here, it has 3 fields: site, visits, and the category. Site is a site name, visits has a total number of user visits, and category has several categories such as search, video, social, portal, etc. On executing this, we must see a new collection created, that is WebRank, executed successfully. In WebRank, there are around 45 documents. Let us cross-check them. Table view. So we have website name, the number of visits, and category fields. We have the data now. The next step is to learn about the single purpose aggregation operations. Single purpose aggregation operations is simple because it has only 3 methods: count, distinct, and group. In the MongoDB documentation page for aggregation, as I have mentioned in the previous videos, there is a link for single purpose aggregation operations. On clicking this, you'll be taken to the single purpose aggregation operations document section. As you can see here, single purpose aggregation operations has only 3 methods: count, group, and distinct. We know about count as we have seen in our previous videos. About distinct is similar to the SQL distinct. It's going to select only the distinct values of a particular field from the set of documents. A simple example through a diagram is explained here. In the orders collection, they have made a distinct for this particular field customer ID. So the result is going to be the distinct values of this customer ID. We have 4 documents: customer ID A123, customer ID A123, customer ID B212, and customer ID A123. So we have 4 different documents but with only 2 distinct values.
So on executing the distinct method on this document or on this collection for this field value custom ID, it's going to return only two custom IDs, that is A123 and B212. Recording the group method, it is not suggested to use a group method. You can see here in the MongoDB documentation, as a group method uses JavaScript, it is subject to number of performance limitations. For most cases, the group operator in the aggregation pipelines provides a suitable alternative with fewer restrictions. So under single purpose aggregation operations, we'll be starting with count and distinct method. Later, after seeing about aggregation pipeline operators, we'll be coming back to this group method of single purpose aggregation operations. So we have three methods: count, distinct and group. Let me start with count first. db.webrank.count. This is the method. There is an option, as you can see here, query is an option. On running this, we must get the total number of documents under this web rank. It must be equal to 45. So we got 45 records. The next step is to have a query inside the count method. There are two possible parameters for the count method. It's query and options. Query, as we know, will be filtering the values. For options, we have fields such as a limit, skip and hint. So let us start with query first. Table view. Let me make table view as a default one. Default view mode as table. So from now onwards, the result will be displayed in table view by default. I'm going to select this category search. This is the beauty of Mongo Booster, the IntelliSense. We got 3 as a result. So there are 3 documents with category search. Let me confirm the same using find. Instead of count, it's going to be find. These are the 3 documents with category search. So we have seen about count. The next step is to learn about the distinct method. webrank.distinct. It's going to be the category field. On executing this, we must get the distinct categories in the 45 documents. So these are the distinct categories. So we have around 12 categories. This is how distinct works. Now we have seen about count and distinct method and a single purpose aggregation operations. The next step is to learn about aggregation pipeline. This is very important. Under aggregation pipeline, as I mentioned in my previous video, that there are many pipeline operators. So let us see the key ones. We'll be focusing on these 4 initially. That is a group operator, match operator, sort operator and limit operator. So these 4 will be using initially under aggregation pipeline. Learning well about aggregation pipeline is very important. So let us see how it works. We'll be using the aggregate method for aggregation in MongoDB. This is the method signature db.collection.aggregate. It takes 2 parameters, pipeline and options. In the pipeline, you'll be specifying the pipeline operators. There are around 16 pipeline operators. Few of them are very important, such as group, match, project, limit, skip, sort, etc. We'll be starting with a group operator first. So group operator. The syntax for using the group operator is somewhat different when compared to your previous MongoDB queries. So you'll be specifying the group operators first, and this field, ID field, is must for a group operator. So it's specified here. The ID field is mandatory. However, you can specify a null value to the ID field. That's different. But this ID field needs to be present for a group operator. Then you need to give the expression. Followed by that, you can specify the field name with the accumulator sets, accumulator with expression. It's very simple to understand about expressions. Let me open the documentation page for expressions. Expressions can include field paths and system variables. To make it simple, just understand this particular section of the documentation. You can access the field names using the dollar symbol before the field name. For example, if the field name is user, you can access the field by using $user for an expression. Similarly, for an embedded document, in case user with name field, you can access that using $user.name, whereas the field path to that is user.name. Let me repeat this. So for instance, if your field name is user, in expression you can use $user to access it, and in the case of an field in an embedded document, for instance for user.name, you can access the field by using $user.name. It's as simple as that. So this expression you'll be using for a group operator. Now let us proceed to Mongo Booster. The method name is aggregate, that we have seen db dot. The collection name is webrank dot aggregate method. So we got all the auto suggestions here. We're not going to use this one. In our document, let us do a find to see different document types. Dot find. We got different categories. To start with, let us count the number of websites under each category. That is very easy. We'll be using the sum for that. Let me show about sum here under group operator. So we know the syntax for the group operator. The first field is ID, expression is required. The second one is field, and you will be specifying the accumulator with expression. And for accumulator, below are the options. You can use sum, average, first, last, max, min, all those. Initially we'll be using sum. Let me take to the next line so that it will be very clear. $group. The IntelliSense is showing the API of $group. The ID field, that's a must one. I'm going to specify the category. The expression is going to be the category. So $category, you know about this already. We have seen it in the expressions. then the total number. Total number colon. We are going to use a sum. It's going to be 1. Braces are closed. Here also it's closed. Initially, understanding aggregation will be a bit challenging, but if you start doing samples, you'll be getting used with it. It's very easy and it adds a lot of clarity to your query also. So the grouping field name is total number. That's what the syntax is. This is a field 1. The accumulator we used is sum and the expression is 1. Let me execute this. This is the result. Under search we got 3, under social we got 4, under info we got 9 websites. For example, if you want to check that, you can check this using the find query. Category info, so these are the 9 websites. Dot count, it must give us a count 9. So the results are matching. Oops. The results are matching. Under info we got 9 websites. Under search we got 3 and social we got 4. This total number is from the sum accumulator operator. We have grouped using category. We have successfully done our first exercise using group operator. The next step is to use the sort operator. That's very easy. Group ends here. I'm going to use a sort operator. Come on. Curly braces. $sort. You can see the syntax of sort here. Sort, the field name and the order by which it is going to be sorted out. If it is -1, it is going to be in descending order. If it is 1, it is going to be in ascending order. I want to do this one in descending order. On the total number field, total number, which we have used here, it's going to be descending order, so -1. That's it. On executing this, we must see the results in descending order. Yes, it's successfully done. So we got the top category, that is business, with 11 websites under that, info with 9. So the results are in descending order. If I make this as 1, it's going to be in ascending order. So we got the results listed in ascending order. This is how sort works. So second is done. The next step is to calculate the average number of visits to the website. Instead of sum, I'll be using average. Let me change this into average visits. Average visits. I'm going to use the same here in the sorting, but in descending order. Instead of sum, I'll be using the average operator. You can see how average works here. Next is expression. For expression, I'll be giving the field name. The field is visits. This must give a result of average visits in descending order. On executing this, we got the result ordered in descending order. We got more visits to the category video, then to search, then to social. So this is how average works. The next step is to use a limit operator. That's very easy. $limit. So this is an example for limit. You just need to specify the number of documents required. Let me make it as 5. I think I need to extend this. So we have group, sort and limit. So in the result, instead of 12, we got only 5, which is limited by this limit operator. Similar to limit, you can use a skip operator. That's very easy. Skip. This is the example for skip operator. So it's going to skip the top 5. So we got from news, business. So the top 5 is skipped. The next interesting thing is the match operator. For that, let me open a separate shell. The syntax for match operator is very simple. It's not as complex as that of the group operator. As you can see here, it's match and a matching query. For optimization, it's suggested to use the match as early as possible because match is going to filter the documents based on the queries. So let's see how match works. I'm going to select only the documents with category blog. Match category is going to be blog. So we got all the websites which are under blog category. So this is how match works. Now let me take the top 2 websites which have maximum visits. That can be easily done using the sort operator and the limit operator. I missed a comma here. Sort using visits. -1 and the curly brace. Oops. And let me limit the results by 2. $limit 2. So this will give me the top 2 websites with more visits under the blog category. We got WordPress and Blogger. They have the most visits. We used match, sort and limit for this. The next step is going to be very interesting. We'll be mixing both the match operator with the group operator. I'll be doing it in a separate shell. I'm going to filter the category based on the total number of visits. For this, I'm going to use both the group and the match operator. db.webrank.aggregate is a method. ID. It's going to be based on the category. This is the expression for that. And then the total visits is the new field. And for total visits, I'm going to use a sum of the visits. The expression is $visits. Now we have done with group. The next step is to filter the total visits by 1 million. For that, I'll be using match. Total visits. It's going to be greater than 1 million. Dollar greater than 1,000 into 1,000. So that's 1 million. Group is done, match is done. So we have listed all the websites with more than 1 million visit. Let me make it as 100 million. So these are the categories with total visits more than 100 million. We have did using match operator and the group operator. It's very easy. With group operator, we have calculated the total number of visits for the ID category. Then using match operator, we use the same field name here to filter out the categories with less than 100 million. So we have only the categories with more than 100 million listed here. So this is how match and group works together. Now let us move to an interesting operator, that is the project operator. Under aggregation, we have seen about group operator, match operator. We have used limit, skip, sum and average operators. Now we are going to see about project operator. Following that, we'll be again revisiting the important queries. So let us start with the project operator now. Let me select all the columns using an empty aggregate function. Let us select only 2 columns using project operator. So the result is clear. We have only 2 fields, site and visits. Following that, let me suppress the ID. So now we have clearly 2 fields selected. ID is suppressed. Following that, I'm going to do a substring of sites. So let me select that. So as you can see here, the site field has only 4 characters. That is because of the substring function which we have done over here. Please note that we have 2 site. One is a site variable and another one is a site field. So now we are going to do an aggregate using a group and match. Using a group first, we are going to take the category field and then we are going to calculate the average visits using the average property. So this is using group operator. So let me select this, and on executing this, we're going to see the average visits for every category. Let us find the top 2 categories. So we'll be using ID, visits, sum, and then we'll be limiting by 2. That's because we have top 2 categories for this query. So on executing this, we'll be seeing the top 2 category with most number of visits. So that's business and portal category. In this query, we are going to use the group and match operator. We are going to query based on the ID.
and we are going to list the categories which have visits greater than 100 million. So this is a similar one we have seen previously. Now we are going to see the top two categories in the blog category. We are going to reverse the sort, and then we are going to limit by 2. Let me execute this. On executing this, you can see the sites wordpress.com and blogger.com in the blog category has maximum number of visits. So this query, we are going to project the columns site, visits and category, and ID is suppressed. We are going to sort by visits in descending order. So this is the result. As you can see here, we have the same fields matching in the result. This is how project works as we have seen it previously. ID is suppressed. The visits is in the descending order. Now we are going to do the same sort using category. So as you can see here, we have a category listed here in ascending order and visits in descending order. This is how project and sort works.
So under aggregation, we have seen about group operator, match operator, project operator, and we have used limit, skip, sum and average operators. With this, we are finishing aggregation section. Let us move to the next topic now. Sharding or horizontal scaling is one of the key features of MongoDB and other NoSQL databases. In this section, we are going to learn about sharding, and I will be showing how to do sharding in simple 6 steps. Though learning sharding may not be important for developers, personally I love it as it is interesting and very simple to do. Sharding architecture is very simple. You can easily understand from this diagram. So we have 3 main components for sharding. The first one is the routers or the Mongos. Then we have a config server. Then we have shards. So shards are for horizontal scaling. So the real data will be in the shards. The routers will be communicating with the application, whereas the data about the shards will be kept in the config server. So the config server holds the metadata, whereas router is for redirecting the queries to the particular shards, and shards hold the real data. So a collection will be partitioned and it will be distributed across the shards using a particular shard key. So we have shard key for partitioning a particular collection and distributing across the shards. So these are the simple 6 steps we'll be seeing in the course to demonstrate about sharding. Prior seeing the demonstration, let me take you to the MongoDB documentation page for sharding. Sharding is clearly explained here. As I mentioned earlier, we have 3 main components: shard, Mongos and the config servers. So router will redirect the requests to the shards and it will be using the config servers for that. As I mentioned, shard keys will be used for distributing the data. We'll be using the test architecture, which is given under this title, Shared Cluster Test Architecture under MongoDB documentation. So I'll be using 1 config server, at least 1 shard server. We'll be using 3 shard servers in our case. But for the test architecture, we need 1 config server, 1 or more shards, and 1 router. So we'll be using this test architecture for our demonstration section. Let us proceed to the demonstration now. For our practice session, I'll be using the test architecture, which is provided in the MongoDB documentation that we have seen previously. This is under shard cluster test architecture in the MongoDB documentation. We'll be using a single Mongos, that is a router, a single config server, and 3 shards in our case. So a single router, single config server and 3 shards. So totally 5 servers are involved in our test architecture. Sharding can be done in very simple 6 steps. The prerequisite is that we must have a data directories for the 4 servers. I mean the 3 shard servers and 1 config server. So the step 1 is to create instances of sharding servers which will be listening in different ports.
Step 2 is to create config server. Step 3 is to create a query router and link to this config server. If you see our diagram, which I have explained previously, the query router gets the data from config server, I mean the metadata from the config server about the data in the shards. So query router collects data from the config server about the shards. Then we'll be using the admin database to add these instances as shard instances, and we'll be enabling sharding on our database and the collection which is involved. Then we'll be using Mongoose to insert data. Finally, we'll be validating the data among the sharded instances. So the same steps are given in list format here. Create data directories for 3 shard servers and 1 config server. Start the shard servers on different ports. Start the config server. Using Mongoose, start the query router for the config server and specify the chunk size. Connect to the router. Use admin database. Add shards. Enable sharding on the database and in collection. Populate the data on the DB. Insert the test data and validate the test data. So the same thing is mentioned here in simple format. Create directories, start sharding servers, start config server, start router server, add shards, enable sharding in the DB and collection. So the preview of the commands which we are going to execute is here. We'll be using mkdir to create directories. Then we'll be using MongoD command to start Mongo instances, I mean the sharding instances in 3 different ports. You can see here. Then we'll be starting this config server. Note that we will be using the same MongoD for the config server also. Just the option is different here and here. Here we mentioned this as shard server. Here we mentioned this as config server. And we'll be giving the DB path for that. The next step is to start the router. Router will be linked with this config server. So you can see the config server port used here, as well as the router will run in an independent port, that is 200,001. We'll be specifying the chunk size, data just chunk size. I'll be explaining this while we are in this step in detail. Then we'll be using the admin database, adding the shards, and we'll be enabling sharding in the database as well as in the collection. And finally, in the database, we'll be inserting the test data. The first step, that is to create the directories. Let me do that one by one. Now we have created the directories. We are going to start the shard servers. Shard servers will be using the directories which we have created previously. As I mentioned earlier, we'll be starting only 2 shards initially. Yes, it has started. It started listening to the port 30,001. Now the second shard. This will be listening on port 30,002. Waiting for connections on port 30,002. So that's done. The next step is to start the config server in port 40,001 in this directory. Waiting for connections in 40,001. Following the config server, we need to start the query router. Query router will be in port number 40,005. Started.
The next step is to connect to the query router using RoboMongo. This is the query router port. We have the configuration database here, and we have the shards collection. Let me query on that. Currently it will be empty because we haven't added any shards there. To add the shards, it's very simple. The steps are given here. Actually, there is one more parameter we can give, that is a name parameter which can be used to identify the shard. Let me provide that. I missed a step because it can run against only the admin DB. I missed this one. Let me open a new shell. Use admin. So switch to DB admin. Let me confirm this again by issuing DB command. Admin database is active. I'm going to execute this add shard commands in the admin database. Successful. We got a reply from the server. Let me confirm it by viewing the documents in the shards collection, which is under config.db. So we got 2 shards. Following this, we are going to enable sharding in the database and the collection involved. Note that this collection and database will be created dynamically. First step is to enable sharding in the database. Done, successful. The next step is to enable sharding in the details collection, where the key field is name. Copy this. Yes, successful. Now we must see a new database here. We got the new database created. Under that, we must have a collection, details collection. Details collection is there. With this, we have done all the configuration steps for the sharding. The next step is to populate test data into the database. Let me do that. On this database, we are under person shard DB. I'm going to insert the test data. It's a simple test data. The collection name is referred here. It's an insert statement where the field name is the shard key. It will insert around 50,000 documents with 3 field names. One is a name, second one is ID, the third one is annual income. The test data is very simple. It will insert into this collection's details collection with 3 fields, name, ID and annual income, whereas the value of I will be from the outer loop. On executing this, it's going to take some time. It must spread the data across 2 shards which we have active now. Insertion is successful. It took some time because I ran it on my local PC. Now to the critical part. We need to see how the data is distributed across the shards. That is very easy. By executing a simple method, you will be able to find how the data is spreaded across the shards. Collection.get shard distribution. That's it. This simple command is going to give you complete details about the data distribution. So we got 21,000 documents in the first shard and 28,000 documents in the second shard. So the distribution rate is 56 to 43. The next step is to add the third shard. You can even confirm this one by connecting to this shard instance. I'll demo it using RoboMongo. New connection. The port is 30,001. Instead of find, I'm going to give here count. $21,798, and here also it will be 21,798. So the counts of documents are matching. Do remember that we inserted around 50,000 documents. The next step is to add the shard. We'll be starting our third shard here. Prior to that, let me copy this command, paste it. Shard will be running in 30,003. It will be named as shard 3 demo. Just preparing the commands. I'm not going to execute it. Prior executing, I need to start the third shard server. It will be running in port number 30,003. Waiting for connections on port 30,003, so the server is started. Next step is to add the third shard server. Let me confirm the database. It's admin. Yes, it's done. Let us reconfirm by querying the shards collection. We must see 3. In JSON view. So we got 3 shards. I'm going to insert the test data again. This time it will be from 50,000 to 100,000. Yes. It's going to take some time, maybe around 5 minutes. The insert is over. Now by issuing this simple method, we'll be able to see how the data is split across the servers. We have inserted around 100,000 records, 100,000 documents. We have new documents in the third shard. The percentage of distribution of the data is given here, around 45% on the first server, 14% on the third one, and around 40% on the second one. We have around 13,000 odd documents in the third server. Let me confirm it by connecting RoboMongo to that. Persons shard DB details collection, view documents. I'm going to count the number of documents here. This count must match. The count is matching with the get shard distribution command. You can also get more details about sharding by connecting to the config database. Let me do it in a separate Mongo instance. separate RoboMongo instance. So under this collection, if you query in the chunks collection, the key is distributed among the servers. Key is splitted across the servers from min and max. The key value started from 3538 to 41,506. This is in shard 3. Similarly, you can query and find the data in shard 1 also. For example, in shard 1, the min and max values are from 8966 and 9999. This is for a particular chunk. And similarly, you can see the databases that has been sharded under this. And for Mongos, you can get the details about Mongos here. And for shards, you know that you have to query in the shards collection. Created data directories. We started sharding servers in different ports. Then we have started config server on a different port. We have linked the config server with the query router, which we started also in a different port with a predefined chunk size. Later, by connecting to the query router and changing to the admin database, we have executed these commands for adding the shard servers and for enabling sharding in the collection. Do remember that these collections are dynamically created. Then we have populated the %shard DB with test data. Later again we added the third shard and we repeated the same step again.
Replication in MongoDB. This is a very simple and interesting one. You can do a simple replication demo in less than 2 to 3 minutes of your time. Replication is the #1 reason for the uptime of our internet-based web services, either it is YouTube, Yahoo or Gmail. Replication is the #1 reason for their uptime. Learning the basics of replication is necessary. Developers may find this topic of replication a bit unnecessary, but my suggestion is just by spending 5 minutes of your time, you can easily understand how replication works in MongoDB. So please just watch a simple demo to understand how replication works. Before starting with our demo, let me take to you the MongoDB replication page where there are 3 simple diagrams so that you can easily understand how replication works. So this is the replication page in the documentation. As you can see here, there are diagrams which explain about how replication works. To start with, let us go to the common architecture. So this is a commonly used architecture for replication where read and writes will be happening to the primary. The dataset will get replicated to the secondaries. Secondaries will be reading the op log to get the data set from the primary. The next architecture is as similar as the first one, but there will be a heartbeat connection between the secondaries so that the secondaries will get elected. In the third architecture, we'll be using a separate arbiter which will not hold any data set. Arbiter's purpose is for just voting the primary or secondary. Based on arbiter's vote, the primary or secondary will be selected. So if you read this line, you'll be understanding about the arbiter's function easily. An arbiter will always be an arbiter, whereas primary may step down and become a secondary, and a secondary may become primary during the election. So arbiter's purpose is just to elect the primary or secondary. Let us start with the first architecture where there will be primary and a secondary. Replication is just a very simple two-step procedure where you'll be starting MongoDB instances belonging to a particular replica set. So this replica set name has to be the same for the MongoDB instances. So assume you have two servers running at different ports in a same machine in a different DB paths, but the replica set names has to be the same. In the second step, you will be adding the replica sets using this command, that is rs.add. So let us do the first step, that is to start two MongoDB instances with different ports, different DB paths, but with the same replica set name. So there will be two MongoDB instances with the same replica set name. So that's a step one. Prior to that, let me create the data directories. mkdir directory is created. Then to start the MongoDB instance, we know that the default port is 27017. So let me make it as 27020 for the primary, and similarly for the DB path it is C data or EPL 1 DB. That's done. The next one is very important. This is case sensitive, so make sure that you have a capital letter S over here. So -- RPL set PL set. I'll give an identifier name as REPL1 demo or REPL1 underscore demo. So waiting for connections on port 27020. Primary is started. Let me confirm that using RoboMongo. Connected. It has only the local database. It doesn't have any other thing. The next step is to start the second MongoDB instance, that is for the secondary. First step is to create the data directory for the secondary. Data, in the one we have used REPL underscore REPL1 underscore DB. Here it will be a REPL 2 underscore DB. Data directory is created. Next step is to start the MongoDB process. Port, for the previous one we have used 27020. Let me use 27021 for this. The DB path, here we have the DB path data / REPL 2DB. Then comes the important one, that is a replica set name, REPL set. So do remember that this is a capital letter, S is a capital letter. So if you miss that, this command will show an error. REPL 1 underscore demo, REPL underscore 1 underscore demo. So the secondary is also started. It's in port number 27021. So RoboMongo. Prior to that, let me do the second step also, that is to add the secondary to the primary. rs.add host and the port. So we are connected to the primary. Open the shell. Let me do a rs.initiate first.
So there is no configuration specified, so it is going to use the default one. You can see in the JSON view. This is very important. My machine name is AMA50 and the port is 27020. This will be using while adding the secondary. Let me check the status. So this one I'll be copying and using. Next step is to add the secondary, because we have already started the secondary in 27021. Successful. Now I am going to create a database and a collection in the primary, and on connecting to the secondary we must see the same database and the collection in the secondary also. So create database, demo replication DB. Database is done. Under collections, create collections, student DB. Oh, it has to be student collection. Collection is done. I'm going to insert some dummy documents. Altering, save. So we got one document here, that is with student name Aldrin. The next step is to connect to the secondary. Again, I'll use a RoboMongo. The port is 27021, right? Edit 27021. Connected, save, connect. So as we expected, you can see the collections got replicated. So this is in the second one. You can check the host info by right clicking here, go for host info. It will say which is the machine you have been connected to. I mean the instance. So we are connected this one to 27021, that is the secondary. Or start status. This is important, syncing to the primary server. This is a primary server port, right? And our current one is 27021. This is the primary server port, that is 27020. So this demos us how replication works in MongoDB. Let me insert few more documents in the primary. Insert documents. So the name is Phillips. Refresh. View documents. We got 2. The same one in this. We got 2 here. So this is how replication works. It's very, very simple, as you have seen. It's just a 2-step procedure. We created 2 instances of MongoDB, but with the same replica set name. Then we added the secondary to the primary. That's it.
MapReduce. This is an important topic to learn in MongoDB. Though it has been replaced by aggregation, MapReduce gives you independence so that you can use your own JavaScript function to condense the data. For MapReduce, we have two types of demonstrations. Initially, we'll be using RoboMongo software to demonstrate. Then we'll be using MongoChef. MongoChef has some inbuilt wizards to ease up the process. So we'll be using both RoboMongo and then MongoChef to demonstrate how MapReduce works. MapReduce has simple 3 steps: query, map, and reduce. So in the query stage, it will be selecting the related documents, which will be fed to a map stage, where the map will act on each document and it will emit key value pairs. For those keys which has multiple values, the reduce function is applied, which condenses the output to an aggregated data. Generally, aggregation pipeline gives you a better performance when compared to MapReduce, but as I mentioned earlier, MapReduce gives you complete independence, so you can play with the data. This is the MapReduce documentation page in MongoDB. As we have seen this before, we have 2 stages, map and reduce stages, and we have a query and output stage. As the diagram explains here, we have a query stage where we'll be applying a query, which will be given to a map phase where the document is mapped and then key value pairs are emitted. If it has multiple values, then the reduce will be operating on that to give the desired aggregated value. So this is very, very simple. Let me recollect again. We'll be applying query first to get set of input documents to the map stage, and the map stage will be acting on the individual document to give key value pairs. If there are multiple values, then reduce operation will be reducing it. So finally, we'll be getting a condensed aggregated data. We'll be using RoboMongo to demonstrate about MapReduce. Then we'll be using MongoChef in our upcoming demo.
For MapReduce, we'll be using db.collection.MapReduce method. The method syntax is given here. As you can see, the parameters map, reduce, and the optional parameters out and finalize. To understand it simple, have mentioned the steps here. The first step is to query. The second step is to map, where you'll be filtering or sorting the records. The third step is to reduce it, that is to summarize the result which we got from map. The fourth step is to finalize, that is for beautifications. This is an optional field. Initially we won't be using it. And the final one is going to be the out, where we'll be saving the output to a collection or to a file. So this is also an optional field. Let us see how to use MapReduce method in our MongoDB collection. I'm going to use a collection called students. Let me create that collection first. I'll be using RoboMongo for this demo. The first step is to create a database for MapReduce demo. Database is there. Next, a collection. I've created a collection. Next step is to insert documents into this collection. I'm going to create a simple document having some students details. So this is going to be our structure of the documents in our collection. We'll be having a student ID field, student name field, total marks, and the year. Our current collection doesn't have any records now. I'm going to insert a set of student records using the insert many method. I think it's in table view. It got inserted. Let me execute the find query again. In table view. From the documents inserted, you can observe that we have data for 3 years, that is 2010, 2011 and 2012. For 4 students, that is Arun, Kamal, Charles and Mary. We are going to use MapReduce to find their average total marks for this 3 sets of data. I mean for the year 2010, 2011 and 2012. Before proceeding further, Let us check the method API. The method takes two parameters, I think mandatory parameters, that is map and reduce, and in the optional we have other fields. Map is a JavaScript function, reduce is a JavaScript function. Then we'll be using out for this example. Let us see the description of out. It's a string or document. Specify the location of the result of the map reduce operation. You can output to your collection, output to your collection with an action, or output inline. So we have three different options. Currently we'll be outputting to a collection. So the first step is to create a map function. The second step is to create a reduce function. And the third step is to have a out where the results will be saved. New shell. Create a map function. That's very easy. Map function equal to, it's a JavaScript function. The function is just going to do emit. This refers to the record. We'll be using only two columns. One is the student ID and another one is the total marks. This is a student underscore ID, comma this dot total marks. Let me view this in JSON view to select the exact text. So with map, we have selected the fields which we are going to work on. The second step is to create a reduce function. That's very easy. The reduce function is going to take two parameters which we have selected here. The first one is going to be the student ID and second one is going to be the total marks. In reduce function we are just going to calculate the average, so let us return that. The average of total marks, right? Array dot sum of this total marks in divided by total marks dot length. So we got the sum and the average. So with this we have created our map function and reduce function. Map function selects a field, reduce function reduces it to a single field. The third step is to call the map reduce db dot the collection name dot map reduce method. We know that the first argument is the map function, the second one is a reduce function, the third one is going to be out the collection name, result underscore map reduce. This is very simple. I'm going to execute this one first. Done. This Done. Now the third one. Let us refresh the collections. We got the result. View documents in table view. So we got the average value calculated. So F, X, Y, Z, 1, 2, 3. I changed the map function to use a student name field for result clarity. So got the same result. The next step is to use MongoChef instead of RoboMongo. MongoChef has inbuilt set of tools for MapReduce. You can easily learn MapReduce using MongoChef. So we are in MongoChef. I'm going to demo how easy it is to do a MapReduce job using MongoChef. So the first step is to create a database for our demonstration, DemoDB underscore MapReduce underscore 1. Database is created. The next step is to create a collection with some test data. For this, I'm going to import a JSON file so that it will create a collection. Import collections. Import source files. Add the source file. Customer underscore test data.json is a file. This file has list of orders and customer details. So 8 documents are imported and the collection must be created. Our database name is DemoDB underscore period underscore 1. So under this we must see the collection. Yes, we got the collection, that is customer underscore test data. Let us see the values in the collection. So the document has 5 fields: ID field, customer ID, status, price and items. In JSON view, customer ID field, status field, price and items is a array which has both quantity and price. In the documents, as you can see, the cust ID is repeated. For example, in this case and in this case. We are going to use MapReduce to calculate the total purchases by each customer. So we'll be using customer ID field and the price field. The next step is to click the MapReduce in the toolbar. On clicking this, we are presented with a form. The collection on which the MapReduce is going to work on, that is a customer test data. In the form, you can see many tabs. The first tab is the options tab, which specifies where the output has to be. Under output action, we have 4 options: inline, replace, merge and reduce. We'll be using replace. Replace is for creating a new collection or replacing an existing collection. To see what are the other options, click on this icon. Inline, replace, merge and reduce. Replace is what we are going to use. Replaces the contents of the output collection if it exists. If it is not, then it will create a new collection. So I selected the replace option. The next step is to create the output collection. The output collection name is going to be customer reports. The output database is our same database. The next step is to filter the input data. Here you can specify the query. Currently we don't have any query to filter out the data. Let me give a dummy condition: price greater than 0. Price is greater than 0. Next one is map. This is the auto-generated function for map. It emits key and value. In our case, as I discussed previously, we are going to select customer ID and the price field. So instead of key, I'm going to specify this dot customer ID, and for value It is this dot price. Now we have finished map. Let us move to reduce. In the auto-generated code, if you can see here, it takes two parameters, key and values. And we have some auto-generated code. I'm not going to use this. Let me take it out. Array dot sum of the values. Values is the price. And we are returning the reduced value. We are just adding all the price and then returning it. Next step is to beautify the output. So for that we have finalize. The first step is to select this checkbox, that is to use finalize. Similar to reduce, finalize takes two parameters, key and reduced value. I'm going to replace this one. The customer with ID, key value plus has made a total purchase of this is going to be the reduced value which we got from the reduce method. So we are done with finalize. Global we are not going to use now. Now we are going to run the map reduce process. So on clicking this icon here, it's going to run the map reduce process. It successfully finished it. So 8 documents. We have 6 results here. As we have seen previously, ACD is repeated twice and UUU123 is repeated twice. So we got 6 results, 6 records. Let us see the collection, refresh all. We got customer reports collection, open collection view. The customer with ID ABC123 has made a total purchase of 25. Our map reduce job has successfully added the price for every customer and it has inserted into a separate collection. So using MongoChef for map reduce takes less time. It will add more clarity to your work. So I personally and strongly recommend to use MongoChef for your map reduce operations.
We know that regex has become a core platform feature of any software platform. Using them in database is going to enhance your querying skills and saves you tons and tons of your time. MongoDB team has cleverly and consciously integrated regex with MongoDB. Regex can be used in MongoDB in 2 ways. The first one is the simple way, that is you can have the field name, pattern and options directly like this. There is no need of a regex operator. The second way is to use the regex operator where you can use in either one of these types. Note that all the 4 types are for the single purpose. So either you can go with this first format or with the second one or the third one or easily with the fourth one. So there are 4 ways of doing the same thing. So let us see the documentation of this regex operator to understand it furthermore. This is the documentation page for regex. This is available under evaluation query operators in the MongoDB documentation. Regex is Perl compatible. It's mentioned here in the definition, as you can see. And these are the 4 different ways you can use regular expression pattern in your queries. Either you can use regex operator or you can use a pattern directly. So there are some restrictions about when to use regex and when to use pattern. We'll see it in the page down. For options, we have 4 different kinds of options. The first one is I. I stands for case insensitivity. So if we specify I, the search will be case insensitive. M is for multi-line search. X is for extended search, so it will ignore the white spaces and the commenting portions in the regular expression. S is for allowing dot character, so it will match all the characters including the new line character in the search data. Before seeing regular expression in action, just remember these two ways of using regular expression in your queries. Either you can use the regular expression pattern directly like this, or you can use the regex operator for that. I'll be using MongoDB for this demo. So to start with, I'm going to create a database, regex demo db. Under this regex demo db, I'm going to create a collection. The collection name is a demo book. And on executing this insert statement, I must see documents inserted into this collection. Let me refresh this. This is the collection we created. So these are the documents in this collection demo book, and these are all the data of New York Times bestsellers. In the next step, I'm going to search for this particular text using our regular find method. Let me copy this one. And on executing, I must find these two records which exactly matches to the find query. This is our regular search. Now to do the same with regular expression, that's very easy. Just I need to replace this double quotes with a front slash before and after the search text, and there is no need of giving the complete search text because regular expression works similar to our like in SQL search. Now clicking run, the same results are fetched. If you want to check, I'll select both. The down one is the result from the regular expression. So on table view, the results are same. Now to the next step, that is, I'm going to search for the word John. The results are same because we have a John Sanford mentioned in the document. The next step, I'm going to make this John word in uppercase. Of course, it won't fetch any result because the search is in uppercase. So for this, we have an option I to specify the search is in case sensitive. So on placing I after the search text, now we must see the result same as that of the previous one. So results are same. So this is how you are going to add an option for the regular expression search. To do the same with regex operator, it's very easy. You just need to cover this text with a curly brace like this, and then you need to specify regex here. And instead of I like this, we need to specify this as a separate parameter that is called options. So options needs to be specified like this, and it's going to be covered with double quotes. So let me run this one. I got error. I hope I missed a brace. Yes, so curly brace is missing. Let me give that. So we got the same result as that of the previous one. So if you want to specify a regex operator, do remember for the curly brace, it's as similar to all other operators over there. So you need to give the $regex symbol here,
Then you need to give the search text, and options can't be given like this directly. You just need to specify a separate options parameter, and then you have to cover the options in quotes. So this is how regex operator works. Seems to be little complicated than our regular expression search using the find method. Now to the next step. One more thing is to note is that even if you replace this front slashes with quotes, the result is going to be the same. Let me select both. And you got the same results as you can see here. In the next step, I'm going to search John or a word girl in the documents. This is very easy. You just need to specify a pipe operator like our programming languages. So the resultant documents have John or a girl. To search for a single letter is very easy. You just need to have like this with the square braces. So this will fetch you the documents with J in them. And similarly, you can also specify the range easily here like this. This will fetch you the documents with letters J, K, L, M. Just remember the square braces here. So this is for searching for a letter range. Like letter range, you can even search for digit range also. That's very easy. You just need to specify the digits between the square braces. The resultant will have digits in that. To search for text that starts with a certain word, it's very easy. Search for starting text. It's very easy. You just need to use a caret symbol, and then you can specify the word. On executing, we will get the result like this because we know that this one is starting with the word what we are expecting, 15 here. To understand better, I'll do it again. So for example, if you want to search for the text which is going to start with a grit, you just need to specify here a grit. Do remember the caret symbol over here. So the resultant document has the word grit in the beginning. Similarly, to see the documents which ends with a certain word, that's also very easy. For example, to get this text, you need to specify this field is going to end with the word Kalanidhi. That's similar to the one what we have done previously. We used caret symbol to search for starting with, to search for ending with. You need to specify this. Let me view the document first. The symbol here for this is the dollar symbol. If you specify the dollar symbol, it's going to search inside this field where the text ends with this particular word. We got the search result exactly as we expected. In addition to the caret symbol and the dollar symbol, we have few more symbols. Their meaning needs to be understood. Dot character is used for any character match except new line, and the question mark symbol that matches 0 or 1 times, plus symbol that matches 1 or more times, and the star symbol, which is quite frequently used, matches 0 or more times the search text. So with this we have seen about regular expressions. Now let us move to the next chapter. We are going to see about indexing in MongoDB. Generally, those who have database knowledge before know the importance of indexing. Like relations in traditional database, indexing also plays a key role. In MongoDB, indexing holds a very high value as MongoDB is mostly used in a non-transactional environment. By default, MongoDB generates an index on the ID field of every document in a collection. Let us see indexes in MongoDB in detail. Indexes are primarily for improving the performance of your find queries, but the reverse effect is that it will reduce the performance of your insert and update operations. Without indexes, MongoDB is going to search in all the available documents in that collection. So if you have indexes, the particular field will be cached and kept separately. So the search will be performed on that field only, and it will be very faster since most of the indexes will be loaded to the memory. By default, MongoDB creates an index on the ID field and you can't delete that. This is important to be notified. There are many types of indexes. I have listed few here. The primary one is the single field index. As you can understand from the name itself, it is going to index only a particular field. And the second one is the compound index. It's going to create an index on multiple fields. The third one is a multi-key index. This is for indexing fields with array type. The fourth one is a text indexing. We have seen about this for text search. And the final one is the geospatial indexes. For indexes, it's very simple. You just need to remember these 4 methods. First one is the get indexes, is going to list all the indexes available in your collection. Create index or the ensure index is going to create a new index on a particular field or a group of fields. The third one is drop index or drop indexes. This is for removing the index. And the final one, which the database administrators used to do quite often, that is re-indexing or rebuilding the indexes. So to start with, we are going to see how index is going to improve your performance for a find query. We'll be using get indexes, explain method, create index or ensure index. This is the list of key topics we are going to cover for MongoDB indexing. Initially, we'll be seeing these 3. We'll be seeing how to list all the indexes in a collection. Then we'll be searching without indexing, followed by we'll be searching with indexing. Then we'll be comparing the query performance in both cases. So let us start with this 3 first. For this demonstration, I'm going to use Mongo Booster Northwind database. Under Northwind, we have a collection by name orders, which has around 830 documents. So I'll be using that for this. The contents of orders collection is listed here. These are the list of documents present in orders collection. You can see quite a lot of fields over here. To start with, let me check the indexes under this collection orders. That's easy. db.orders.get indexes. So this method is going to list all the indexes available for this orders collection. Let me execute that. So there is only one field which is indexed, that is the ID field, which is by default is going to be indexed. So there is no additional index on this orders collection. Let me do a find again. Now I'm going to search for a customer ID, that is Vinet. This is in the top of the list. Do remember that this customer ID is not indexed. So the find query is db.orders.find. The field name is customer ID and the value is going to be minute.
Let me execute this one. So we have around 5 documents matching it. In the next step, I'm going to measure the query performance of this particular query. That's very easy. Under MongoDB documentation, analyze query performance tutorial is given. So in that, in the beginning, if you can see here, there is a description about the explain method with the argument execution status. This is going to give the statistics of the performance of a query. So I'll be using the same method here on this query. So this must give us the performance details about this query. Let me see the result in JSON. The key thing we have to watch is this one. The total documents examined for this query. It's 830, which is absolutely equal to the total number of documents in the orders collection. This means that MongoDB has scanned all the documents under this collection to find a result for this query. This is a poor performance. This is not appreciable. So let me create an index on this particular field, that is customer ID. So to create index, it's very easy. Just use a create index method. db.orders.create index. On this field, customer ID. On executing this, it must create an additional index on this field customer ID. Do remember that we have an index on underscore ID field by default. Let me run this one. So the number of indexes after is 2, before is 1. So our index is successfully created. To cross check this, let me use the getIndexes method again. We have 2 indexes now. In table view, it will be very clear. One is on ID field, the another one is on customer ID field. So now let me do the same execution stats to see how many total documents have been scanned after indexing in JSON view. So the total documents examined in this case is 5. Do remember that we have only 5 matching documents for this particular query. The query has scanned only those 5 documents which are necessary, not the all 830 documents. So this shows us the importance of indexing. We have seen all the 3 items in this list all the indexes in a collection. We used getIndexes, then searched without indexing, and we have searched with indexing, and we have seen the performance. Now to check the default ID index and then to drop index. We'll do this two together. We know that MongoDB by default will create an index on the ID field. Let us cross check that. For that, I'm going to create a new collection, test ID index. This is the empty collection. Under that, I'm going to insert a document, a plain simple document with a single field. Now we have a document under this collection. The next step is to find the indexes created. Must be a single index on the ID field. So we have an index by default created by MongoDB on the ID field. So this proves us that MongoDB creates a default ID index on a collection. Now to the next one, to drop the index. You can't drop this ID index. Let us create an index on this name field and then drop that. Creating index syntax, you know already. That's very easy. Create index and then the field name. I hope we got 2 indexes now. Now we got 2 indexes.
To drop an index, it's very easy. You just need to do the same. Instead of create index, you have to just give the drop index. So the index was previously 2, now it is 1. Let me cross check it again. We have only one single index now. Drop index worked successfully. We are going to see one of the key thing in database administration job, that is database backup and database restoration. In MongoDB, MongoDump command is for backing up the database in binary format, whereas MongoRestore command is for restoring the binary format back to the server. JSON dump, I'm not comfortable with the name. This has to be called as JSON viewer. This is for viewing the backed up database. So it presents the binary format in human readable format. I mean from JSON format to JSON format. So you can examine the backed up data. The MongoDump command options are very simple. As you can see, you need to provide server details, database name, and of course the output file name. You can even specify a gzip if you want to compress the output file, and also you can specify the collection name or the query so that you can filter out the backed up data. OPlog, this gives you an exact database snapshot. While running MongoDump command, this also records the oplog entries. So later these entries can be restored using MongoRestore command. So you'll get an exact perfect snapshot of MongoDB. And finally, we have noIndexRestore for MongoRestore command. This you can easily understand its meaning from the name itself. This prevents from building the index after restoration. So let us see the documentation first before proceeding to the demo. So let us see the MongoDump documentation. So this is for MongoDump, and the synopsis is given clearly export of the content of a database. And for oplog, so oplog creates a separate file named oplog.bsn. This is for creating effective point-in-time snapshot and can be restored using MongoRestore oplog replay. Now next to MongoRestore, for MongoRestore command, so writes data from binary database dump created by MongoDump to a MongoDB instance. And for noIndex option, this is the one. So prevents MongoRestore from restoring and building indexes as specified in the corresponding MongoDump output. And finally to JSON dump, this is the JSON dump documentation page. It converts the JSON files into human readable formats including JSON. So this is useful for reading the output files generated by MongoDump. So that's the purpose of JSON dump. We are going to see about MongoDump, MongoRestore and JSON dump in the upcoming demo session. MongoDump and MongoRestore can be easily done through the GUI tools. Just by clicking on the menu item, you'll be prompted with a window with many command options. And similarly for NoSQL Manager also, you just need to click this one and a window appears with all the options. So you can do things graphically easily. We'll be seeing this later. So we'll start with the command prompt first. We'll be demoing MongoDump and MongoRestore using the command prompt first, and then later we'll be doing the same through the GUI tools. In the MongoDump, I'm going to dump this collection which is under Learn MongoDB. So articles collection will be dumped to a file and then will be restored to a different database. So this is what I'm going to do through the command line now. The DB is learn MongoDB. So --db learn MongoDB, and the collection name is articles. So that's easy. That's just collection articles. Now the output file is going to be out to E drive temp articles collection. So done dumping of this learn MongoDB articles is the output. 17 documents. So let me check that. Yes, it's 17 documents. Let me view the content also here. This is the one newly created, and you'll be able to see the JSON file under this. This is the metadata file. This JSON file can be easily viewed through JSON dump command. Let me do that. JSON dump, and the path to this file. This one is located. This must show us the JSON content of the JSON file, articles.json. Yes, this is the content shown. So let me verify the content here also. Contents are similar here. Through JSON dump, we were able to verify or see the contents in the packed up articles.json file. Now the next step is going to be Mongo restore. I'm going to restore this articles.json to a new database. I need to change to the path where the backup has been taken. So I have changed to the path. So now my path is eTemp articles collection. Next, I have to run the Mongo restore utility. I haven't set in the class path. So I'll be using the complete path to run the Mongo restore utility. Let me copy this one. Mongo restore. Now I have the option from which database to which database. The database is learn MongoDB. I'm going to make it as 2, and the source is learn MongoDB. Oops, I just need to cover this within quotes. This is because we have a space between program and files path. So as you can see here, building a list of collections to restore from learn MongoDB directory, reading the metadata, and then it has successfully restored to MongoDB2. This is a new database which it has been dynamically created using Mongo restore command. So 17 documents. Let me check this through the GUI. In the GUI tool, a new database is created and the count in the collection is matching with the command line option. As you can see here, 17 documents. Here also we have 17 documents. So Mongo restore has happened successfully. In the next step, we are going to use NoSQL Manager tool to do the Mongo dump and Mongo restore activity. So we'll be using these two icons here in the NoSQL Manager tool. I'm an NoSQL Manager for MongoDB. So the first step is to do the Mongo dump utility. So I'll click this icon. On clicking this, you can see here articles collection is selected already, and you need to specify the output directory. I'll specify as original. This DB path option is no longer valid. Similarly, directory DB option is also removed from latest versions. To run a repair, you can have a repair option. This will write only the valid data to the output and force MongoDB to scan data store directly. This is usable when you are going to have your customized ID rather than the auto-generated ID. The final option is DB dump users and roles. We don't have anything here. So I'll be just going with only output directory mentioned, and on clicking the run tool icon here, we must see the articles got dumped to this path. So let me open this one to verify the same. I got the articles.json backup of this articles collection here. The next step is to use a Mongo restore utility. Doing a Mongo restore is very easy. Just you need to click this icon which is next to the Mongo dump utility. On clicking this, you'll be seeing the options here. The first one is the path to the database dump. You need to specify the entire path till the bson file. So in my case, it's articles.bson, so I have specified it. As I mentioned earlier, db path option is no more valid. I have to specify the database name here. I'm going to create a new one. I'll be giving a new name here. resto_NoSQL dump. This option obj check is by default checked. This will prevent inserting invalid documents while we are doing Mongo restore. No index restore. This prevents creating indexes or building indexes while we are doing Mongo restore. This filter JSON option is no more valid in the newer editions of MongoDB. And on finally clicking the run tool here, you must see a new database created with the articles.bson content. Let me do that now. So we got the new database with articles. Let me double click this to open. And under data section, I'll be able to check whether the number of documents restored are 17. Yes, it's 17. So we have successfully used the restore tool in NoSQL Manager to restore the dumped data, which we have done through Mongo dump tool here. With this, we have successfully done Mongo dump and Mongo restore using command line option previously like this, and by using NoSQL Manager. It's similar with Mongo Booster also. It's also wizard based. So on clicking Mongo restore in the menu option, we'll be getting almost a similar form where you need to specify the path or the bson file for restoring. Let me move to the next section now. We have successfully finished with Mongo dump and Mongo restore. We are going to see one of the reasons why MongoDB is so successful and interesting, because they have customized their product based on the requirements. In addition to the regular collection, they have added two more type of collections. One is limited by size and another one is limited by time. We are going to see about the one which is limited by size, that is called capped collections. These are designed for high throughput. So let us see more details about this interesting capped collections. As I have mentioned earlier, capped collections or fixed size collections. So while creating the collection, you will be specifying the size, and also note that there is an option parameter where you can specify the maximum number of documents that can present in that collection. So this is the syntax for creating a capped collection. It's as similar to the regular collection. The difference are these three parameters. The first one is you need to specify capped as true. The second one is you need to specify the size. The third one is optional one, where you can specify the maximum number of documents that can be present in that capped collection. You can easily convert an existing collection to a capped collection. One more interesting thing about capped collection is that it maintains the insertion order. So when it reaches the data cap, I mean the maximum size allowed, the old documents will be removed and the new documents will be inserted. Since it maintains the insertion order, there is no query index is present, and thus it has a high throughput. So they are mainly used for logging and in caching data. Irrespective of these advantages, there are a few disadvantages also. You can't delete documents, you have to drop the entire collection. And similarly, when you want to update a capped collection, you need to create a separate index for that. And finally, we don't have sharding support for capped collection. This is one of the important things. So you need to handle your data carefully. Now let us see a demo session to understand it very clearly. So let me demonstrate about capped collection using RoboMongo software. It's very easy. So the first step, I'm going to create a database for this. Capped demo DB. I'm going to create two collections here. One will be capped, the other one will be uncapped, I mean the regular collection. So that we'll be learning the differences quite easily. Let me open the shell first. Create a regular collection. That's easy. You know that a db dot create collection, and just you need to give the name of the collection. This is a regular collection. I just named as regular. Successfully created. The second one is going to be the capped collection. It's capped. The only difference is the arguments we are going to pass in the option field. Syntax is this. You need to specify capped as true. Size you need to specify, and optionally you can specify the maximum number of documents. So the first thing is capped is true. Second one, then the next option is size. Let me specify as 1024. And finally, max documents, I'm going to specify as 5. Created. And these are the two collections we got. Now I'm going to populate values into these collections using a simple for loop. The documents are going to be very, very simple. So for I less than 100, I plus plus. Here I'm going to insert it. Collection name is capped dot insert. The document format is going to be simple so that understanding will be easier. A name is X plus I, and the age is I plus 10. On executing, oops, I missed a brace here. Let me execute it again. So we got records inserted. Let me do the same with the non-capped one. That's a regular collection. Inserted successfully. Let's view the contents. This is the specialty of capped collection. There will be only 5 documents irrespective of the insert count. Only 5 we got. If you see in table view, it will be very clear. In the capped collection result, you need to observe 2 things. One is we have only 5 documents. That is because we have restricted the max number of documents to 5, as well as all the old documents got replaced by the new ones. That's what we have specified as FIFO, first in first out. So whichever got inserted first got removed first. Let us check the regular collection now, because we have inserted 100 into regular collection also. We got many documents. Let me do a count of this to confirm the same. It's 100. We inserted 100, we got 100. But in case of capped collection, though we have inserted 100, we got only 5. So this demos us how capped collection works. The next key topic is we need to see how deletion happens in a capped collection and in a regular collection, because we can't delete documents in a capped collection. So let's check that. db.capped.delete. I'm going to take the name from this, copy value. Similarly, let me make a find command after that to check the same. I executed this, and on finding there is no deletion happened, and you can see the values here. So the result remains the same. But in case of the regular collection, it will be different. First, let me select that. So the value is there. This is in regular collection. Now I'm going to delete this. Done. And on selecting, there is no records. So this is how the regular collection works. Delete is easy. You can do that. But in capped collection, you can't delete. And if you need to delete it, you need to just drop this collection. So this is one of the main difference between capped collection and the regular collection.
Since MongoDB is schemaless, there is always a design decision needs to be made either to go with embedded documents for your data structure or for related documents. In case of embedded documents, we'll be having a main document under which the subdocument content will be embedded inside. For related documents, it's totally different. We'll be having different documents. They can reside either in the same collection or in a different collection like this. But all these documents will be related by using a key, like our relational databases. For a simpler data structure, embedded documents are preferred, and for complex one and for large data sets, related documents are preferred for manageability. There are many blog posts recording this decision, either to go for embedded documents or related documents. This post under blog.mongodb.org explains you the 6 rules of thumb for MongoDB schema design as very good information. This is from the lead technical support engineer. The other blog is this one, that is under openmind.net, which has a very good presentation which can help you in deciding either to go for embedded documents or for relational documents. The conclusion is that when your document structure is going to be smaller or very fewer, go for embedded documents. For other case, you can go for the related documents. We are going to focus about embedded documents in this section. For our demonstration, I'm going to create a separate collection. Operating systems. Under this, I'm going to insert multiple documents. The first one is OS, or it will be the ID column. ID is 100. Yay. And the version is XP. The year of release is 1998. Done. I'm going to insert 3 more values. This one will be B and this one will be C. The next one is Vista. I think the year is 2007. This one is 2009. That is 7. Done. So we got 3 different documents. Now the main document. These are the related documents. Now the main document will have this ID related to them. So let me have one more insert. Take out this. OS, Windows. Company is Microsoft. Versions. Here we are going to give the ID of these documents. Done. So view documents. In JSON view. As you can see here, the documents are related using their ID number in the main document. For embedded documents, this will be different. These document contents will be directly embedded inside the main document. Let us see that. So the content is going to be the same. I'm going to create a new document just to demonstrate how embedded documents work. ID needs to be different. So for embedded documents, we don't need any ID. This is going to be Vista. Here is 2007, 2009. There is some. Inserted. View documents. Then view in JSON view. As you can see the document structure here, this is the difference between the related documents and the embedded documents. Embedded documents, we have embedded the contents directly here, but for us, for related documents, we'll be having a ID field which is referring to the related documents. These related documents can be present in the same collection like we did, or in a different collection. So this is the main difference between embedded and related documents. For embedded documents, we have the content embedded inside the main document itself. One of the coolest, simplest and very useful feature of MongoDB is TTL indexes. TTL stands for time to live. So when a collection has TTL indexes, all the documents will be automatically removed after certain seconds. This TTL index feature shows how flexible MongoDB is when compared to the traditional databases like SQL Server or Oracle. Though there are many use cases for these TTL indexes like session, cache, log management. We use TTL indexes for log management in our company. We have around 6 different types of collections with TTL indexes. The syntax for TTL indexes is very simple. You just need to specify the field name and the expiry after seconds. So just note that this is not milliseconds, it's in seconds. You can't use compound indexes on TTL indexes. You can't use TTL indexes on capped collections because you know that capped collections can't be deleted until all the documents are removed. And you can't use TTL indexes on ID field.
Now let us see a simple, easy demo using TTL indexes in MongoDB. To demonstrate, I'm going to create an index under log events collection on the field created at, which is going to expire after 100 seconds, which is roughly equal to 1.5 minutes. I'm going to insert test data. So let me do the first step first. On executing this, as you can see here, it has created a collection. Number of indexes before is 1 and after is 2. Now I'm going to insert test data into that. I'm going to execute this multiple times so that we get a lot of data in the collection. Refresh it. View documents. As you can see here, we have multiple data under the collection log events, which is going to expire after 100 seconds. So let me check it. It is there. Yeah, now it has gone. As you can see here, there are 0 records and the time is 12:10 now. We started at 12:08. Let me recollect what we have done. We have created index and we have set expire after seconds to 100, and then we did a find. So after the seconds expired, the data has gone. So this is how TTL index works. It's very easy, but very, very useful.
In MongoDB, we have two methods, save and insert, almost doing the same, but there is a little difference in both of them. So that's what we are going to see here. When you are going to use save, it will do upsert, means if the document is not found, it's going to create a new document. If the document is pre-existing, it's going to update or replace the document. This is where insert differs. Insert, if it finds ID predefined there, it's going to throw error that this particular ID already exists, or else it is going to insert a new document. This is how save and insert works and differs. Let's see practically to understand their differences. I'm in Mongo Booster. I'll be using this product DB. Collection name is call_products for this save and insert demo. As you can see here, there are 4 documents in this collection. I'm going to start with insert first. I'm going to insert a pre-existing ID. Redocument db.callProducts.insert. This is the document. The value is already present here, so we must get a duplication error. As we expected, we got a duplicate key error. I'm going to do the same using save method. And one more small change I'm going to do is, instead of 999, I'm going to make it as 1, 2, 3, 4, 5. On executing save with a duplicate key here, it will update the document successfully. Matched, modified. Let me find it again. In table view. So we got the document whose value is updated. This is the main difference between the insert and the save method. Insert doesn't allow duplicate keys, whereas save overwrites it. So it has overwritten this document. To make this insert successful, you know that either you can remove this ID field so that MongoDB will auto-generate, or you can give your own ID field. So in my case, I'm going to give my own. It's 88. And then executing this will make this successful. Inserted is 1. In table view, let me find it before that. So in table view, the insert is successful. Save does the same when you're going to take off the ID field or you're going to give a new ID field. In this case, I'm just taking off the ID field. And this value I'm going to change as 555. And on executing, save will also insert a new record. Table view. We got a new record like that of the insert. The only difference is whenever a duplicate key is found, insert stops executing, whereas save updates the document. That is the main difference. That's what we have discussed previously here. We are going to see how to use Java with MongoDB. It's very easy and simple because the API is very clean. It must not take more than 15 minutes for a Java developer with MongoDB experience to get things done with MongoDB. The setup process is very easy when compared to other languages such as PHP, C# and Node.js. The API is very clean and very simple, as I mentioned earlier. The important point to note is that the version 3.x that we'll be using has a different API when compared to the previous versions, that is 2.x. We'll be using the latest version, that is 3.3, to demonstrate the features of the MongoDB Java driver. These are the 5 steps you need to do in your MongoDB project using Java. The first step is to create a Maven project using Eclipse. The second step is to install the MongoDB driver using Maven's pom.xml file. In the step 3, you'll be making a database connection. Then you'll be connecting to a database and to a collection in that database. After connecting to a database and then to a collection, we'll be doing actions such as projection, CRUD, gridfs, etc. And finally, the important step is to close the connection which you have opened in step number 3. So don't forget to close the connection. These are the key classes and methods we'll be using. From the name itself, you can understand their functionality. For instance, Mongo client represents the client which you are going to connect. Mongo database, Mongo credential, Mongo collection. Document has a different name. It is not Mongo document, it is just document. And Mongo cursor is used for looping through the records. There is an important package called model. Under this, we have key classes such as filters, sorts, projections, and aggregates. These classes provides beautiful static methods which can be used in your code. In the Mongo collection class, we have key methods such as delete many, update many, bulk write, etc. So this class, that is Mongo collection, plays an important role in your coding. Then we have 2 other important packages, that is gridfs and then async. Gridfs is used for gridfs functionality and async is for asynchronous operation using the MongoDB driver. In our Java demonstration, we'll be doing the following steps. The first one is we'll be listing databases, then we'll be listing collections and its contents. In the third step, we'll be creating a new collection, inserting a single record, multiple record, finding records with query. We'll be sorting the records, we'll be filtering it, and we'll be using projections to filter the column selected. And similarly, we'll be using update, delete many, drop collection, and drop database. These 3 are very important. That is bulk write. This you'll be using quite often. Run command. This is a simple method but very powerful. It allows you to execute the MongoDB command against the database easily. Gridfs. For gridfs, we'll be uploading a video or image to a MongoDB collection using Java MongoDB driver. Before proceeding with the lab session, let us see the MongoDB documentation page for the Java driver. This is the documentation page for the Java driver, and you can see here various versions are listed. To install, we need to add this dependency to the POM file of Maven. Let us see the reference for the release 3.3.0. Under this reference, click on the MongoDB driver link and you can see here get started. On clicking this, it has 3 sections under this: installation, quick tour, and admin quick tour. On clicking installation, it mentions about the dependency that needs to be added to the pom.xml file. The quick tour is important and very clearly organized. How to make a connection is explained here using the Mongo client class. To insert a document, the steps are mentioned here, and similarly to add multiple documents, the steps are mentioned. For querying a collection, how to use a find method is mentioned here, and similarly to find all the documents in a collection, we'll be using the cursor, Mongo cursor. That's also mentioned in the quick tour session. And finally, it mentions about the bulk operations. In the admin quick tour session, it explains about the admin activities, that is how to list the database, how to drop a database, drop a collection, create an index. All those admin related activities are clearly mentioned with a sample. The important one among this is run command method, which is in the bottom of the admin quick tour session. It helps you to run any command against MongoDB. On clicking this link command, it takes you to the MongoDB commands list.
This link has a problem because, as you can see here, there is a double front slash. On removing this, you must be able to see the available commands for the MongoDB. These are the commands you can run through the run command function mentioned here. Now let us start with the Eclipse. The first step is to create a Maven project. Let me create some dummy artifact and group IDs. So we got the Maven project created. The next step is to add the dependency. This is the pom.xml. Under installation section, let me copy the dependency part and paste in my pom.xml. On clicking save, you can see here the workspace is building. Under Maven dependencies, you can see here we have MongoDB driver, bison jar file which is required, and the driver core. So these are the three new jar files which has been added. Now let us start with the demonstration list. The first one is to list the databases available in the Mongo server. Step 1 is to get the connection. Oops. We'll be using Mongo client class for this. Here you can mention the server address and the port, or you can go with the default option. In our case it is 127.0.0.1 and the default port is 27017. We got the connection. Step 2 is to list the databases. Client dot list database names. As you can see here, it returns a Mongo iterable class. So let me do that here. It's going to give me the database names, Mongo iterable. The result is going to be string. The next step is to loop through this Mongo iterable interface. So if you see the documentation for a Mongo iterable interface, it's given here, and under this interface there is a method for each which will loop through the contents, which in turn uses a block class. This block interface, if you can see here, used for some logic against the given parameter. We are going to use this one and we are going to override this apply method of block. Back to our code. We are going to iterate through this using the for each. It's going to be new block, string class, and then this. System out the string here.
The string here is going to be the DB name. On running this, we got 3 databases listed: DB demo, demo and local. Let me cross check using Mongo Booster here. It's the same. You can see here DB demo database is there, demo is there, local is here. One more important thing I missed is to close the connection. So I need to close it after using this one. Connection is closed. Now we are done with the first one, that is to list all the available databases. The next step is to list the collections and its contents. The next step is to list all the contents in a collection. That's easy. We need to get the database first. DB equal to the client dot get database. The database name is DB underscore demo. Now we have to get the Mongo collection. The collection name is tbl underscore login. Let me cross verify the same. DB demo tbl underscore login. It has around 40 documents. Now we'll be using the same iterator to loop through this collection. Mongo iterable. It's going to be a document. Collection is equal to collection dot find. Next step is similar to the previous one which we have done. Instead of string, it's going to be the document because we are looping through a collection. And then here also doc contents. I'm going to print the doc contents to JSON. And this is because of this. What we have done is we got the database first, then we got the collection from the database. We created an iterator. Then we are looping through the iterator to print the document contents. Let me run this. So we got the document contents listed. The next one in the list is to create a new collection. That's very easy. So on the same code, I'm going to create a collection. DB dot it's create collection. Collections underscore user details. It's returning void. On running this, we must see the new collection created.
So we got the collection without any document in that. The next one in the list is to insert single and insert many. Let me create a new Java class for this. Demo inserts. The preliminary steps are same. That is to connect using Mongo client and then get a handle to the database and then get the collection. So instead of this TBL login collection, we'll be using the user details collection, COLS user details. To insert, we need to create a new document. That's very easy. Document. Append. String and object value is there. Username. Admin. And then one more append to give the password. Admin 1, 2, 3. So we have created a new document. This document needs to be inserted. That's very easy. Collection.insert 1 and the doc name. And finally, we need to close the connection. Let's run the program. Refresh here. We got one document. Right click view documents. Admin 1, 2, 3. So we inserted the same. Username is admin and the password is admin 1, 2, 3. Username, password. If you want to see it, you can see it in JSON view. Now let me create multiple documents and do a multiple insert. That's the next step. Insert many. The next step is to insert many documents. So for this, I'm going to create an array list of documents. Now to this, I'm going to add multiple documents. Document 1, document 2. This is going to be admin 1, admin 2, admin 3. Let's go 1. Let's go 3. here we are going to use insert many, and then we are going to give this list of documents to the insert many function. I mean insert many method. On running this, we must see these 3 new documents added to the existing list of 1. It's done. Let me click view documents. So we got 3 more added to the existing one. So we got 4 documents. These 3 are from the insert many. It's very simple, and the API is very clear. Now let us proceed to the next one in the list. That is to use find and to do find with query. We have seen about insert and insert many. The next step, we are going to learn about filtering, sorting, and projections using the find. So let me create a class demo find. And for this class, I'll be using the same connection properties and the same collection. So I'll be copying this code block from here to here. The next step is to loop through this collection and then print all the documents. For that, we have the find method of collection.find. Just note that find method returns a find iterable interface. The result is going to be the document. The next step is to loop through this iterator to print all those. So that's very easy. We'll be using the for each method of that. It has to be a block type. This is going to be of a document. We need to override the methods, add unimplemented methods. And then in the body of the method, I'm just going to print the document in JSON format. On running this, we must see all the documents in the collection. So we got all. So let me move this to a separate block, separate code session. There's a print block. And I'm just going to use this here. On running this, we must get the same result. Now the code is readable. In the next step, we are going to see how to sort the documents. For that, as I mentioned earlier, we'll be using the model package com.mongodb.client.model. Under this, we'll be using the sorts class. For sorting the result, I'll be using the sorts and then the sorts class. Under this, we have ascending and descending. I'll be using the descending, and the field name is going to be username. On running this, the result is in descending order. So this is how sorts works. Descending is a static method. So as you know that, we can do an import static. Sorts.stop. So we can take it out. The code is now readable. The next step, we are going to see how to filter the result. I'm going to use the equals method that is available under filter class. So the same, instead of sorts, I'll be using filters. Filters dot equal, the field name is username and the value is going to be admin3. Filters can be removed because it's a static import. That's done. On running this, you must see a single result because admin3 we have filtered. You can also do an AND condition here. I'm going to do a not equal to. That is NE. Here also NE. That's not equal to 1 and not equal to admin3. So we'll be getting the other two. I mean admin and admin2. I have used the AND condition and I'm using two filters, that is not equal to, not equal to. So as we expected, admin and admin2 is listed. It is in reverse order because we have sorted the result. So this is how filters and sorts work. It's very easy to do that. Now let us see how to do projections. We have seen how easy it is to do sorting and filtering using the driver. Now let us see about how to do projections. Projections are used for listing only the required fields and leaving out the other ones, similar to the select star in our regular SQL query, where we'll be selecting the columns necessary and filtering out the unnecessary ones. For that, similar to filters and sorts, we have projections under model package. So this is the one. A static import has been made on projections class. So let me do the projections here. Dot projections. We have include and exclude method in projections. So include the field names. In my case, I'm going to include the username only, and I'm going to exclude the ID column. I mean the ID field. So that's it. Now let us run the program. As you can see here, we got only the password and the username field listed here, whereas the ID is filtered. What we have done is we have used the projection method, and then we have used the include and exclude from the projections class. You can even exclude ID using the exclude ID method, and you can add additional columns here like this, password. So the result will be the same. So this is how projection works. In our listing, we have seen about sort, filters, and projections. Now to the next one, that is update. After update, we'll be seeing about run command and gridfs, and finally we'll be seeing about bulk write. So let us proceed with update. I'm going to do it here itself rather than going for a separate class for update, because it's very simple. So collection dot update one will be doing first, then we'll be going for update many. The first one we need to filter. I'm going to change the password of this one where the username is admin. Update where the username is admin, and I'm going to set the value of password as admin 0. And set the password. The set method is available under model.updates class. So updates.star like this. Update is going to happen for a document with username as admin, and we are going to change the password to admin 0. Done. Let's check here. They have successfully changed the password to admin 0. The next step is to demo multiple updates, that is updates many. So instead of update 1, it's going to be update many, and instead of equal, I'm going to take as greater than. The ID field is greater than 0, or I'll take not equal to 0. I'm going to introduce a new column, user ID. Instead of set, I'm going to increment here, user ID as 1. So let's see what's happening. Again here in table format. So we got the user ID. This is the functionality of update many. Previously we did with update 1. Now update many is done. The next items in our list are bulk write, uncomment, and gridfs. Before seeing these three, let us see the delete and delete many, and drop collection and the drop database, because these four are easy when compared to this one. Now to delete. Delete is similar to the insert. So collection dot delete 1. I'm going to use the same. So this is going to delete when the username is going to be admin. Prior to that, let me check the current documents here. So this must get deleted. So that's gone. Next is delete many. That's very similar to the delete 1. Open to your code format. Prior to this, I'm going to insert some values into the collection. I mean some documents into the collection. db dot call user details dot insert username, it's going to be admin, come on, password is going to be admin X. I'm running it many times so that I'll be getting quite some records to do delete many. In table view, 1 2 3 4 5 6, so 6 records I got with the username admin. So on using delete many here, it must delete all the usernames with admin. Prior to that, let me show delete one first. Delete one will delete only the first matching document. So we got 5. Initially we got 6, now we have 5. So delete one deletes only one, whereas delete many, it's going to wipe out all the documents matching this criteria. So this is how delete many works. So we have seen about update one, update many, delete one, and delete many. Note that for update we have used set and inc method. These methods are from the updates class, which is available under this model. It's a static import. So we have seen delete many. Now to see drop collection and drop database, let me create a temporary database. I don't want to touch this one. Temp test or db is a database name, and under this I'm going to create a collection, demo users. So collection is done. Under this collection, I'm just going to insert some dummy data. So under this collection, we have around 5 records. We are going to drop the collection first, then we'll be doing a drop database. So let me create a new class for this. Drop a demo. I'll be using some code from the existing ones. The database here is different, that is temp underscore test underscore db, temp underscore test db, sorry, temp underscore test db, and the collection is going to be demo underscore users, demo underscore users. We are just going to drop this collection, collection dot drop. So this must take off the collection. Let's refresh here. Collection is gone. We have called the drop method. Now let us drop the database because collection is no more. Drop. This must take out the database. So database is gone. We just called the drop method in the DB, and similarly we have called the drop method in the collection. We have seen delete many, drop collection, and drop database. Next we are going to see about run command. Then we'll see about bulk write and gridfs. This is run command demo. I'll be using this portion of the code. Now we are going to see how to execute commands against MongoDB. For command reference, please visit this section, that is database commands under reference. To start with, I'm going to use a simple command, that is to get the server status. Run method, it's going to return a document which we are going to print. And then the print. To JSON. On running this, we must get the server details. So we got the server info, put the host details, all those details here. Similar to this, you can get the database status also, that is DB stats, I hope. Yes, we got the DB stats. Similarly, we can get the collection status. The command for that is col states. This is the one we are going to use. So col states. And then the collection name. The details of the collection is presented here. There are many interesting operations you can do with this. For instance, you can shut down the server, you can copy the database. Try by yourself. This is a very useful method for doing such operations. We have seen about how to execute commands against MongoDB. The next one in our list is how to use gridfs. Using gridfs is very simple. Need to create a bucket equal to the first buckets dot create. I'm going to create a bucket first to save a file. The DB is this one, that's DB demo, and the bucket name is equal to demo temp bucket. I'm just going to save a file in this bucket.upload stream. This is the one we are going to use, upload from string. The first argument is a string argument. That's going to be the file name, line stats, and then here it's new file, input stream, new file, this is the file. It's ctemp langs.jpg. This must create a bucket for us, that is demo temp bucket, and then langstats is a one we'll be using for this file. So let me run this using Mongo Booster. Refresh. So we got the bucket. On double clicking this, the file is revealed. On clicking view file and selecting the appropriate application, this is the file we saved using gridfs bucket. Upload from stream. So this is how gridfs works. Similar to upload, you can even download from the gridfs easily. So now we have seen about how to execute commands against MongoDB, and then we have seen how to use gridfs. The last one is bulk write. I'm going to create a separate class for that. Let me use the same code block. We are going to see how to do a bulk write using MongoDB Java driver. This is a bit challenging when compared to the previous topics what we have seen for this MongoDB Java driver usage. We'll be using the bulk write method in collection class. If you check the API here, it mentions about bulk write, and then a list which extends the write model. Write model has many subclasses such as delete many model, delete one model, insert one, replace one, update many, and update one. So if you are going to use delete one, you need to use this model, and if your document is for updating, you have to use this model and add that to the list which is shown in the API. Now let us see how it works. So in a batch operation, I mean the bulk operation, I'm going to do two inserts, update and a delete. So for clarity, let me create the documents first. Doc insert one is equal to new document, which is going to take username, insert one, and I'm going to append the password. PWD insert one. Similarly for insert two also, I'll be doing the same. Insert two, and the password is going to be insert two. Now for update, we just need to set the value for the update. This is for doc update. The original document, it's going to have the username. Let me get the username from here. The username is going to be admin2. The updated one, I mean the new one, is going to have a username admin to modified, and the command execution for setting this is going to be different here. Update command, new document, we have to provide the set operator here, and then the document name. You might have already known about this, a set operator. Now we did an update. Just to recall what I have did, I have created an original document. This will match the query and the new document which is going to replace this. But do remember that we need to use a set, or it is going to just change the structure of the document with the new one. So I have used a set operator. It has to go in the form of document. So